Welcome to Basic Electrical Engineering. It's lecture number 11. We are studying loop analysis, and today we'll solve a problem where we have a current source in a loop. This is a special situation. If we have a current source in a loop, we don't write KVL equation for that loop. We just assume the current of that loop to be equal to that of the current source. Here we have an example where we have two loops, and in loop number 1 we'll assume two currents, I1 clockwise. I told in my earlier lecture that I1 can either be assumed to be clockwise or counterclockwise. So we assume it to be clockwise here, and I2 is also clockwise. This is our assumption. So we don't need to write equation for loop number 1. For loop number 1, we have a current source having value 4 milliamperes. So we'll write I1 to be 4 milliampere. Why positive? Why not negative? Because the direction of I1, our assumed current, is the same as that of 4 milliampere current source. Therefore, it's positive. If the directions would be opposite to each other, we would write I1 is equal to minus 4 milliampere, right? So here they are all in the same direction, therefore write I1 is equal to 4 milliamperes. So for loop number 2, we need to write a KVL equation, right? So we have three components in loop number 2. This 4K resistor, 6K resistor, and this 5 volt voltage source. To write an equation, we have to write the voltage drop across each of these three components. Let's consider this 4 kilo ohm resistor first. 4 kilo ohm, the voltage drop across 4 kilo ohm resistor is 4K times, since there are two currents flowing through it, I2 is going upwards, I1 going downwards. We are in loop number 2, we'll assume I2 to be the highest, I2 minus I1. The net voltage drop in this direction. Right. Then we have the 6K resistor. So the only current flowing through this 6K resistor is I2. 6K I2. And then this 5 volt source, since the current enters from the positive side of this 5 volt source, it will be considered as a voltage drop, and we'll write it positive. Plus 5 is equal to 0. So we know I1. So if we put I1 here, we'll have one equation and one variable that we can solve easily. This is 4K I2 minus 4 milli plus 6K I2 plus 5 is equal to 0. So multiplying this 4K, this becomes 4K I2 minus 4 4s are 16, and we know that kilo when multiplied with milli becomes 1, because kilo is 10 to the 3, milli is 10 to the minus 3, multiply, the answer is 1. Plus 6K I2 plus 5 is equal to 0. So we have this 6 plus 4, 10K I2 this minus 16, when it goes to the other side of the equation, this becomes plus 16, this plus 5 becomes minus 5, so we have 11. I2 is 11 over 10 milliampere, because 1 over K is a milli. So we have computed I2 to be 11 over 10 milli. We already know I1 to be equal to 4 milliampere. Right. Now we are asked to find voltage drop in this polarity across this 6K resistor, and we call it VO, V sub O, V out. How would you compute it given I1 and I2? we have I1 is equal to 4 milliampere, I2 is equal to 11 over 10 milliamperes. How to compute V out? V out is the voltage drop across 6K resistor in a direction so that the left side is positive, the right side is negative. When the current enters in this direction, when the current flows through the 6K resistor in this direction, it causes this polarity. The left end becomes positive, the right end becomes negative. So the current that enters the 6K resistor from the left side and leaves from its right side is I2. So according to Ohm's law, the voltage drop should be the resistance times the current flowing through it. V out is 6K times I2. And we know I2 is 11 over 10 milli. This kilo cancels in milli because 10 to the 3, 10 to the minus 3. 2 3s are 6, 2 5s are 10. So it becomes 33 over 5 volts. One other voltage that you want to find out is across this 4 milliampere current source. We are asked to compute this voltage. Maybe let's call it V out 2. It's a 4 milliampere current source. So how would you find voltage drop across this current source? The current in this loop, of course, is 4 milliampere. The current flowing through this branch is 4 milliampere. But what's the voltage drop across it? For that, we cannot apply Ohm's law because we don't know its resistance. Its resistance is assumed to be very high. So, in order to find voltage drop across it, we have to write KVL equation for loop number 1. Let's write this KVL equation. In loop number 1, we have 3 components, this 2K resistor, this 4 milliampere current source, and this 4 kilo ohm resistor. Let's write KVL equation. 2K times I1. The first term is 2K times I1. The voltage drop across this 2K resistor. Since we have to find out voltage drop in this direction, so this is plus V out 2. Because current enters from the positive side, its voltage drop. Plus 4K. How many currents are there in through this flow through this 4K resistor? I1 going downwards, I2 going upwards. Since we are in loop number 1, this is I1 minus I2. So we know I1, we know I2. Let's put these values. We know I1, we know I2. So we have only one unknown in this equation, that is V out 2. So let's put these values. I1 is 4. So what is it? 4 here, 4 milli. 2K times 4 milli. I1 minus I2. 4 milli minus 11 over 10 milli. So 4 2s are 8. Plus 4K times 40. 40 minus 10 4s are 40. 40 minus 11 is 29 over 10 milli equal to 0. So this is 2 2s are 4, 2 5s are 10. So this is 8 plus V naught plus 9 2s are 18, 8 1 2 to the 5, 58 over 5 is equal to 0. Solving this, taking all these constant terms on the other side, the answer is minus 98 over 5. This is the voltage drop across this 4 milliampere current source. We will continue solving problems related to loop analysis with some special cases in our next lectures. Thank you.